So probability counting technique again. This is a little more in-depth question. We'll talk about which of our counting techniques to use. There is a board of directors that consists of 3 people. Okay, so there is some position at the top, and it consists of 3 people, we'll say. Okay, so you got 3 positions. Position 1, position 2, and position 3. They are chosen from 5 chiefs and 7 VPs. So you got, we'll say chiefs. So you have 1, 2, 3, 4, 5 chiefs. And then you have 7. We'll just do V. 1, 2, 3, 4, 5, 6, 7. So from this, they're going to choose 1, 2, 3 guys, and they're going to place them into these positions. Okay? They just don't know who they're going to do them with yet. What's the probability that the board consists only of chiefs? So only of chiefs. So are we talking about permutations, combinations, fundamental counting principle? Okay. Here, a permutation is when the order matters. The order would be, think of the idea like we actually have names for the chiefs. Okay, so because I'm not very creative with our names, we'll just call them chief 1, 2, 3, 4, and 5. So we would use a permutation if they asked us what's the probability that it's going to be chief 1, 3, and 5. So the order is important, okay? Or chief 1 will be the first director, chief 3 will be the second director, chief 5 will be the third director. That's order is becoming important in these situations. So that's where we start to use a permutation. Permutation has many more possibilities, right? The idea that what if chief 1 is the 1, chief 3 is 2, chief 5 is 3, or what if chief 1 is 2? Chief 3 is 1, Chief 5 is 3. That's a different order. Again, that's where our permutation kind of comes in because the order is important. In this question, they just said, what's the probability that 3 of them are chiefs? It doesn't matter. It could be the last 3 guys. It could be the first 3 guys. It could be the middle 3 guys. They don't care. So when order is important, okay, when order is important, we use a permutation. When order is not important, so we don't care about order, we use a combination to calculate things. Okay?
Yeah.
So the first question is they're asking us, okay, is what's the probability the board consists of only chiefs? Okay, so we need to figure out how many ways you can choose 3 chiefs out of a total of 12 people. Or sorry, five people, sorry, because there's only 5 chiefs.
Yeah.
Okay, how many different ways can we choose 3 of these guys, whoops, out of the total of 5 of them? Okay, so this becomes, again, the order is not important, so we have a combination. Combination is NCR, okay, so N combine R. So there's a total of 5 guys.
Yeah.
Okay, and we need to choose 3 of them. How many different ways can we do that idea? I think this is usually written as N factorial, N minus R factorial times R factorial. I think that's usually your combination. Yeah, it is. But you probably have a calculator where you can kind of do that. This one becomes 5 factorial over 2 factorial times 3 factorial. 3 was our R. And then 5 minus 3 was 2, so we have 2 factorial. Okay. And again, that's going to be a pretty different number. Let's just kind of use our calculator here. This one has functions. I can take functions. I think I have factorials in here. Here we go. Combinations. So I'm going to use this combination. So the first is our N. So we have 5, choose 3 is equal to 10. So what it's telling me is there are 10 different ways to choose 3 guys out of the chiefs. Okay, so that's how many different ways we can choose. That's how many different ways we can choose 3 chiefs. So that was actually become our numerator. Okay, so we have our, we can choose 10 chiefs, or sorry, we can choose 3 chiefs 10 different ways, right? I can go 1, 2, 3. I can go 1, 2, 4. I can go 1, 2, 5. I can go 2, 3, 4, 2, 4, 5, 3, 3, 4. Like that's the idea, okay? But we have to figure out how many possibilities there are. And remember, originally, they're also supposed to be chosen from some VPs too. So there are 5 chiefs and 7 VPs, okay? So there's a total of 7 plus 5. There's a total of 12 people.
Okay.
Really up for grabs here. So again, a combination because the order doesn't matter. But this combination, okay, consists of, it's out of 12. How many people are we choosing out of this 12? How many positions are there? Do you remember how many board of director positions there were?
There's 12.
There's 12 people. We chose
3.
Yes,
Yeah.
so just choosing 3. So now the question is asking is, how many different ways can we choose 3 guys out of a total of 12? Okay, so let's calculate that and we'll make sense of the 2 numbers at the end there. Same idea, we use that combination. I'm going to quickly use it in our calculator again. Let's change these numbers to be 12 and 3. So we can choose 3 guys out of 12, 220 different ways. So 220 different ways. So this is the probability. So let's talk about how we got that probability. We decided that there are 10 ways to choose the Chiefs, and there's a total of 220. That becomes a 1 in 22 probability. So how did we kind of get those numbers? We have to say what we wanted for each. Because they're asking for the probability, the first thing is, we'll call it our NA. Okay, they wanted to know the probability of choosing 3 Chiefs. So probability of choosing 3 Chiefs. And the Chiefs were out of the total of 5 Chiefs. And then on the bottom, we'll call it our total number of choices here. And I guess we'll call this event A instead. Call it event A over event B. Event B is how many options there are total. Okay, so how many different ways, what's the possibility of choosing, or number of possibilities for choosing just 3 people? So our probability was possibilities for choosing 3 Chiefs over the possibilities for choosing 3 people out of that lot. That's how we set this 1 in 22 up for our combinations.